to our experience, it doesn't give us any instability problem. May produce some performance problem, but not stability. All right. Have any questions so far for this technique? No? You know? You're happy with it? Or you are happy with it? Well, if you don't say nothing, I assume you're happy with it. Good. All right, and this is real applications. I'm going to show you some real applications in NASA there. This technique has been used in what we call control structural interaction CSI model. That's the model. Yeah, CS model. CSI means control structural interaction. And this is a huge structure. This is not small one. Look at the people there. And this is larger than or taller than a person. This is the antenna. This is the structure we are talking about. They are truss structures. And also that they are flexible. And they are low frequencies. It's not high frequencies. So that creates some problem. All right. Let's see what is next. The objective is design a controller to suppress the structural vibrations. Now we are using several different approaches, but one of them will be we call optimum second order controller using acceleration feedback. That's the one you're learning now called AVA, the active vibration observer. That's what we call for this virtual controller. And of course, that to determine those the control design parameters, we use some optimization technique. In other words, we assign a performance objective. For example, we say we want a damping more than 5%. Just like your homework, I give you 5%. Assume I want a 5% damping. How can I do it? Also, assume I don't want to move my frequencies too much. So I assign that the closed loop frequencies is identical to your open loop frequencies. That means your natural frequencies. If that that's just like in your homework. Right? So the advantages of this approach is this bias robustness. Well, it's just called robustness. Bias means there's another different meaning, but it's really stability. This control force for the same amount of damping. Measurement noise is robustness means they can tolerate a lot of measurement noises. Simply because the stability, they are stable. Other advantages. Okay, and this is just a sketch how the system works. So we have a total of the 8 called servo DC accelerometers, the one you saw just a few slides ago. And this distributed 1, 2, 3, 4, 5, 6, 7, 8. Total 8 different accelerations. Then we have also 8 collocated with this called the thrusters. We have thrusters. Those are core gas thrusters. It's the core, the CO2 thrusters. It's not really like the space thrusters. You cannot do the space thrusters in the lab. So you have to use those not poison gas. So CO2. You can buy it from the market. Okay, and then there's a laser beam on the top of it. That laser beam will shoot the laser to this antenna here and reflect to the top of the building, and there's a target here. The target there receives the laser from this top of the struck beam, shoot to the antenna and to the target. And this is just to see the effect of the vibration of these structures and the antennas to your target. If you have a vibration in your truss structures, then when you shoot from here to there and then reflect to the top of the building, then your target will be moved around, right? It won't be exact, stay there in one point, the target point. That's what happened here. And from one end to other end, the truss is like a 15 or 20 meters, between 15 to 20 meters, because in the US they always use a feet, so it's 55 feet, like that. So that's about between 15 to 20 meters. And the ceiling from this truss to the ceiling is about 70 feet. So it's about less than 30 meters, about 75 feet. Okay. So the virtual passive control you learned already here, and that's what you learned. Use the Excels. All right. Guarantee stable for actuator sensor collocations. Again, since it's only mode by mode basis, so what we do is we just design like 8 different TMD. So each pair of the thrusters on Excel we count as one set. So this is like a TMD, right? But this is not real TMD, it's virtual TMD. It's really done by the computer. So we have 8 of them there. 8 TMD. Sounds good? Any problem? Any questions?